Today, we're going to learn about preparation of insoluble salt. And some of you are yet to settle down. I need everyone to settle down so that we can move together. There's still a lot of noise. So let us begin. We are learning about insoluble salt. I'm going to bring to us some notes here. I hope you can see the notes. The notes present here. Preparation of insoluble salt.
Mommy.
Mute everyone. Mute everyone.
Yeah.
Please mute everyone.
I mute everyone. Okay, just a minute.
Jangan.
Okay. So today we are going to learn about preparation of insoluble salts. And when you talk about an insoluble salt, this means that when the salt is added to water, then it will not dissolve. It is insoluble. I need to Christ. Just a minute, I need to remove this disruption. Just a minute, I think the misbehave that is here cannot allow me to continue. Okay, I think we are fine now. Those who are misbehaving have no opportunity to misbehave again. Let's move on. Sorry, we've wasted some time there. Now, today we are going to learn about preparation of insoluble salts. And from what you can see from the screen, there is, ignore the number 5, but I would want us to look at one of the methods. We will look at two of them. One of the methods is called direct synthesis. The word direct actually means or helps us to know that the method is involving combination of two elements. It is a direct synthesis. Synthesis means it is the sort of combination. It is synthetic. It is something that is being carried out. Direct synthesis. And one of them is in the preparation of iron 2 sulfide. From the word iron 2 sulfide, we can easily identify the two elements being used. Now, the first element is iron, and the other one is sulfur. There's a procedure here. A spatula full of iron filings is put in a crucible. Then a spatula full of sulfur. Then the iron and the sulfur are mixed well in the crucible. The mixture is heated strongly until it glows red, then the source of heat is removed. The reaction continues by the heat produced by the reaction between iron and sulfur. Gray iron metal reacts with sulfur, yellow sulfur solid to produce black iron 2 chloride. The equation for the reaction is here. Iron plus sulfur gives iron 2 sulfide. The equation is very important for you to note it. And then the product is allowed to cool. I would want us to watch a video in the same so that we exactly what happens. And again, I would want you to keenly note what really happens during the reactions. There are some caution that is usually there. Just a minute. Just a minute.
Just as a warning, this reaction produces highly poisonous SO2 gas. This must only be carried out in a well-ventilated area or a fume hood. Also, the reaction between iron and sulfur is extremely exothermic and very high temperatures are reached. Ignited using a hot glass stirring rod, iron powder and sulfur powder react together extremely exothermically. For this experiment, only iron and sulfur powder is needed. The amount that you need will depend on how much you want to make. You can make any amount as long as you maintain the mass ratio of 7 grams of iron to 4 grams of sulfur powder. First, I added 35 grams of iron to 20 grams of sulfur. I then poured the powder between each beaker back and forth until the mixture became relatively homogeneous. When mixing the powders, this is often the best method to use. Mechanical stirring, or even worse, grinding with a mortar and pestle, could lead to the spontaneous ignition of the mixture. You might notice that there are still quite a few clumps of sulfur in the final mixture. For our purposes, this is okay. However, if you wish to avoid this problem, simply use dry sulfur and fully powderize it before using it. Now that we are done mixing the powders, we are ready to react them. The best and most impressive way to set off the reaction is to simply heat up a glass rod and place it into the powder. The temperature of the glass stirring rod only has to be a little over 100 degrees, which is the melting point of sulfur. When the sulfur melts, its reaction with iron will begin. So the reaction that's going on here is actually quite simple. Simply put, the solid iron and the liquid sulfur combine to form iron 2 sulfide in an extremely exothermic reaction. This reaction should only take place on something that can withstand the high heat. This means it should be carried out on something like concrete or a high melting point metal, not aluminum, because aluminum will melt at around 600 C. Also, absolutely no glass, porcelain, or organic polymer of any kind. This reaction is interesting, but the final product, iron 2 sulfide, is actually a useful product. The iron sulfide from this reaction can be collected and reacted with hydrochloric acid to produce hydrogen sulfide gas. It has a rotten egg smell and it is extremely poisonous. Its toxicity is comparable to that of hydrogen cyanide. However, despite its significant toxicity, hydrogen sulfide gas is used in a multitude of chemical processes. I'm providing this video to show you why you should not carry out the reaction on glass or porcelain. The reaction is extremely exothermic and it can easily crack and shatter glass. In the end, you are left with a very hard, dense material that is stuck to the end of the glass stirring rod. If you are interested in keeping the iron 2 sulfide, then you can wait till it cools, break it up, and put it into a container. Just as a warning, powdered iron 2 sulfide is pyrophoric, which means that you probably shouldn't powderize it as it might ignite on contact with air.
Okay, that is a video. The video is showing us how iron and sulfur is prepared. I'm not sure whether there are any questions there, but you can unmute yourself in case you have a question. Yes, we can move on. So in one of the methods of preparation of a insoluble salt is where you take the elements themselves and then you combine them together. Once you combine them together, you heat them, and then you will have prepared salt. Now note that the reaction is highly exothermic. From the video, once it is ignited, a lot of heat is produced, and then the heat is helpful in the reaction. Most reactions with iron are very exothermic. So that is one method of preparation of insoluble salts, direct synthesis. It is also called direct combination. That is, you take two elements, you react them together, and the result is an insoluble salt. And the result is an insoluble salt. So that is one method. We're going to go to the second method. Let me bring the notes here. Look at precipitation reaction. Ignore the number 6. Precipitation reaction. That means there will be formation of a precipitate. It has two names. The first one, I'm not sure whether you can see this cursor. This is what that is highlighted here. That is double decomposition. It is also referred to as double decomposition, either double decomposition or ionic precipitation. Actually, it involves precipitating an insoluble salt. So what is used? In the preparation of insoluble salts, one of them being lead 2 sulfate. It involves mixing 2 soluble salts. We've already learned about soluble and insoluble salts, so you can refer to that. Let's look at this procedure. 10 centimeters cubed of lead 2 nitrate. Yeah, you put it in a beaker. So the first thing is you identify the soluble salts that you're going to prepare to use. And the first one, in the preparation of lead 2 nitrate, we're going to use this soluble salt, lead 2 nitrate. Lead 2 nitrate is a soluble salt. And the reason as to why we are using lead 2 nitrate, it is because it will provide us with the lead ions. It will provide us with the lead ions. So that's why I'm taking 10 centimeters cubed of lead 2 nitrate and then put it in a beaker. To the same beaker, add excess magnesium sulfate solution. So magnesium sulfate is a soluble salt. The reason as to why we are using magnesium sulfate, it is because it contains the sulfate salt. Now remember, our aim is to prepare lead 2 sulfate. So in the preparation of lead 2 sulfate salt, which is insoluble, we're going to use lead 2 nitrate and magnesium sulfate. Now you note in salts, we have lead 2 nitrate with the lead ions, and we have magnesium sulfate with the sulfate salt, with the sulfate ions. So from there, you mix the solutions with a glass rod. Then the solid is allowed. So once you mix the two solutions, the solid is allowed to settle. Then the liquid is poured off. The solid is washed with distilled water. It is filtered and dried between filter papers. In this reaction, the metal ions of the salt exchange ions of their salts. That's why it is called a precipitation. This type of reaction is called double decomposition. It is a double decomposition. When two salt solutions react, lead 2 sulfate and magnesium nitrate salts are formed according to this equation. Now this equation is giving us the summary of what has happened. We have lead 2 nitrate and magnesium sulfate. So there will be exchange of ions. So this sulfate will combine with the lead to form lead sulfate. And the magnesium combines with nitrate to form magnesium nitrate. Now note, lead 2 sulfate is an insoluble salt, while magnesium nitrate is a soluble salt. So in summary, we would say, in the preparation of an insoluble salt, step number 2 is where you use 2 soluble salts where the ions exchange. And once the ions exchange, then there's formation of an insoluble salt and a soluble salt. These are examples of precipitation reactions. So the salt formed here is lead to sulfate. Reactions in which solids are formed are called precipitation reactions. The solids formed are referred to as precipitate. So we have other examples here. We have barium sulfate. That's an example of an insoluble salt. Calcium carbonate, lead-2 iodide, and silver iodide. Before we go through these examples, I would want us to watch a small video in the preparation of lead-2 iodide. The preparation of lead-2 iodide, so that you can see the procedures themselves. Okay, let's look at the
we're looking at making an insoluble salt by a process called precipitation. Now, in everyday life, precipitation means hail, snow, rain, sleet, drizzle, all those sorts of things. But in chemistry, it's got a more precise meaning, and it means when you make an insoluble solid from a solution or from 2 solutions. Here I have 2 solutions. We can tell that they because the solutions are clear. In this case, they also happen to be colorless, but the 2 words don't mean the same thing. For example, copper sulfate is a solution. It's clear, you can see through it, but it's blue. In these 2 instances, they're both clear and colorless. A solution must be clear. So I'm going to put a bit of lead nitrate in a beaker. And then I'm going to add some potassium iodide, and we're going to make lead iodide. And as you see, it goes bright yellow, but also it goes cloudy. It's murky. You can't actually see through it anymore. So how are we going to get the insoluble solid out of that? Well, to do that, we need to filter it next. So filter paper, fold it in half, fold it in half again, sit it in our filter funnel, and hopefully, just to get it to sit properly, you can sometimes just dampen it a bit so it sits in the filter funnel properly. And then we're going to filter off our yellow insoluble solid. Being insoluble, it shouldn't come through the filter paper. You will find that a trace of it does in this case because the particles are so fine, but most of it will stay in the filter funnel. And so what we're going to end up with is mainly a solution of soluble products and our insoluble precipitate of lead iodide.
in the filter funnel. We'll just have a closer look at that. There you see that the yellow solid is already sort of sticking, gathering, collecting on the filter funnel. And what is filtering through is mainly transparent and colourless, mainly soluble stuff. There's a tiny trace of some yellow solid there, but not so much as we want to worry about. So that's the first stage in obtaining an insoluble salt, in this case lead iodide. Now this technique has some useful everyday applications. One of them would be if we want to identify different dissolved ions. For example, if I thought I had lead ions dissolved in a solution, I could add a few drops of potassium iodide, and that would immediately give that bright yellow precipitate. And that is a characteristic test for lead ions. But another and probably more useful application of precipitation is the way in which we can remove soluble metal ions from solutions. For example, we know that lead is very poisonous, and we wouldn't want, for example, a solution of lead ions going into a river. So if a factory that's been working with lead has got some waste products, some effluent, some wastewater, rather than discharging it directly into a river, it would want to make sure it removed any toxic lead ions, and so they can do this by precipitation. First of all, mixing the chemicals together, the solid settles to the bottom, and once it's insoluble, of course, it can't be absorbed, you can filter it off, and you've got, as in this case, an almost clear solution coming out with little or no lead ions dissolved. So hopefully what's coming through the filter is pretty much harmless, or at least it's got no lead ions in it. And that's precipitation. We're going to leave it for a while to carry on filtering, and then once it's finished filtering, we're going to rinse the solid with distilled water, because the damp solid will still have some of the soluble chemicals. Might be a bit of excess lead nitrate, or more likely, because I'm using a stronger solution, some excess potassium iodide might be mixed in with the damp lead iodide. So I'm going to rinse it afterwards with distilled water. And now it's nearly finished filtering, so here's my solution. I'm just going to rinse it now thoroughly with distilled water. That will, as I say, get rid of any potassium iodide excess that is still in there. And once that has been left dry, you could put it in an oven or just leave it in a very in a warm place. You could dry it off and you'd be left with pure lead iodide.
Okay. So that is the second method of preparing insoluble salts. That is using two soluble salts. So once you mix those two soluble salts, you get an insoluble salt. Now in that case, as you have seen, there was lead to nitrate plus potassium iodide. That is one of the best examples because, just a minute. If you have a question, you can raise your hand so that I can see. So if you, for that example, that is when you mix potassium iodide and lead to nitrate. It's one of the preferred examples because the precipitate formed, that is lead to iodide, is yellow in color. So you are able to see the yellow color and so on and so forth. Now, having given you two videos about the preparation of insoluble salts, there are two key things that you will need to know. And this is where we take time as teachers so that you can be very careful and know, number one, the procedure of preparing the insoluble salt, and number 2, the writing of ionic equations. Let's start with the number 1, the procedure of writing a procedure in the preparation of insoluble salt. Because I am going to give you an insoluble salt, I would want you to identify the 2 soluble salts that are going to be used in the preparation of that insoluble salt. For example, I gave you lead 2 sulfate. Lead 2 sulfate is an insoluble salt, and therefore, to prepare lead 2 sulfate, I will need 2. Let me go back so that we can get this straight. It's very important for you to note, to be able to write down a procedure on how to prepare. When you're given an insoluble salt, for example, lead 2 sulfate, are you able to identify the 2 soluble salts that will be mixed together to form the insoluble salt? I'm going to give you some examples. We have already looked at this procedure. Let's look at these examples. We have other salts that can be prepared in the same way. We have barium sulfate. Now, barium sulfate is an insoluble salt. So we need 2 soluble salts that will help us in the preparation of barium sulfate. Now, the reaction between barium nitrate and zinc sulfate will give us barium sulfate. Now, I could give you a hint, and maybe in your list of soluble salts, it's good to know that all nitrates, whichever nitrate you identify, it is soluble. All nitrates are soluble, and therefore, barium sulfate, you need a soluble salt of barium, and you need a soluble sulfate. And you can see barium nitrate is one of the soluble salts, and zinc sulfate is one of the soluble salts. And now this gives us barium. When you mix barium nitrate with zinc sulfate, you get barium sulfate and zinc, which is insoluble, and zinc nitrate. It is a soluble salt. So once you mix these 2 soluble salts, barium nitrate and zinc sulfate, you get an insoluble salt, barium sulfate, and the zinc nitrate. Zinc nitrate is a soluble salt. What happens is that there is ion exchange. So the barium ions in a barium nitrate will exchange with the zinc sulfate. So the barium ions will combine with the sulfate ions to form barium sulfate. So number 1, when given an insoluble salt, are you able to identify 2 soluble salts that will be mixed together to form the required insoluble salt? That's one example. Another example is copper 2 carbonate. The reactions is copper 2 chloride and sodium carbonate. Again, your knowledge on soluble salts is very key, because that's what will help you know. I've already given you one hint. All nitrates are soluble. Another hint would be all potassium, all sodium, and all ammonium salts are soluble. So that can help you even in the identification of soluble salts. So once you react copper 2 chloride and sodium carbonate, you get copper 2 carbonate. There is ion exchange. The copper ions will combine with the carbonate ions to form copper 2 carbonate plus sodium chloride. That's an example. The third one is what we have seen in the video, where we have lead 2 iodide as the yellow precipitate. When you react lead 2 nitrate, which is a soluble salt, and potassium iodide, it is also a soluble salt. Remember, all potassium salts are soluble. All sodium salts are soluble. So these can be good sources of soluble salts. So once you combine lead 2 nitrate and potassium iodide, the ions will exchange so that the lead ions in lead nitrate will exchange with, will combine with the iodide ions in potassium iodide, and they'll form potassium iodide. Potassium iodide is the insoluble salt that we are preparing. And then there's a preparation, and then there's lead 2 nitrate. It is the soluble salt. It is a soluble salt. And the last example is silver chloride. It is also an insoluble salt. You need to identify 2 soluble salts that will be combined or mixed together to form silver chloride. And an example is silver nitrate. We said all nitrates are soluble. So choosing silver nitrate is an example of a soluble salt. Again, sodium chloride. We said all sodium salts are soluble. So an example of sodium chloride is okay. So silver nitrate and sodium chloride, when they are mixed together, you form silver chloride, which is an insoluble salt. And what is happening is that the silver ions in the silver nitrate will combine with the chloride ions in sodium chloride. So the silver ions and the chloride ions will combine to form silver chloride, which is insoluble. You can see there's an S here. And then the sodium nitrate solution is going to be formed. I've given you those 4 examples so that you can know, you can come up with the examples of 2 insoluble salts, 2 soluble salts that can be used to form an insoluble salt. Now, I want to go back to the class so that I can know that we are together. Any question? Any question? Or we can move on?
Yes, you can move on.
Okay. Can move on, okay. Now, so the first thing, we really need to know how to write the procedures. So I'm going to go back to my notes, and then I show you the keywords. I hope you have something to write on so that you can get the keywords. Remember, procedures are always asked. Number 2, there are keywords the teacher is going to look for. Now, with that, let's go back. We are going to look at this procedure. You have already identified the solutions. Look at the first one. 10 centimeters cubed of lead nitrate is put in a beaker. You have to identify the first solution. Note, we are preparing lead 2 sulfate. You must identify a soluble lead ion, a soluble lead salt, and a soluble sulfate. So in this case, it is lead 2 nitrate. So the first statement, 10 centimeters cubed of lead 2 nitrate is put in a beaker. Then to the same beaker, add excess magnesium sulfate solution. Now note what is excess, so that lead sulfate is going to be formed in excess. We don't want any lead ions to remain. So to the same beaker, add excess magnesium sulfate solution is added. Then mix them. Now that gives us 3 half marks. 1 half mark is identifying one of the solutions, which is lead 2 nitrate. The other half a mark is identifying the magnesium sulfate and then mixing them. Once you mix them, then how will you separate them? You can use decantation. The solid is allowed to settle, then the liquid is poured off. That is one method of separating the insoluble salt and the soluble salt formed. Another way is by filtration. You filter the mixture. So this will give you another half a mark. Then the solid is washed with distilled water. That is a key point. You have to wash it so that you can remove any excess magnesium ions and nitrate ions. You wash, I think the video was very clear. You wash with distilled water. So after washing with distilled water, the last one is you filter and then you dry between filter papers. That is the key. Those are the key points for you in writing a procedure for the preparation of an insoluble salt. Allow me to repeat. I hope you'll be in a position to write this, or probably I would send the notes. Remember, it is the first 3 steps. Those are the key things, and I have again identified the important parts. This, you take the salt, one of the soluble salts, lead to nitrate, you add it to magnesium sulfate, and then you mix them together, then you separate them. Here you can use decantation or filtration, but filtration is the best because you filter and then you wash. You filter, and then you wash, and then you dry. And then you dry. Now, I would want to give an example of an insoluble salt, and I would want someone to give us a procedure. Probably I'll share my screen so that you can give us a procedure. Number 1, identifying the insoluble salts, the soluble salts that will be used in the preparation of the insoluble salt. Now let's take an example. I'm going to give us silver chloride. Actually, I've given you that example. Now, using my screen, I would want someone to tell us, to just give us a procedure. How can you prepare silver chloride? Let's have someone. Is there anyone? Yes, Kevin. Kevin, you've raised your hand. You can unmute yourself and then tell us. Kevin, where are you?
The first step.
We are preparing silver chloride. Silver chloride.
You add 10 centimeters cubic of silver nitrate in a beaker. Then in the same beaker, you add excess sodium chloride. Then the solution is mixed with a glass rod. Then allow the solid to settle. Then the liquid is poured off or filtered. Then the solid is washed with distilled water, filtered and dried between filter papers.
That's very good. That's very good. It's good because you are able to identify the 2 soluble salts. That's very good. Let's look at something else. Zinc, you can mute yourself. Zinc carbonate. Zinc carbonate. Zinc carbonate. Gibson. Gibson, mute yourself. Zinc carbonate. Zinc carbonate is an insoluble salt. Zinc carbonate is an insoluble salt. And I would want someone to give us a procedure on how to prepare zinc carbonate. Joshua Macau, you've raised your hand. Joshua Macau, unmute yourself and give us a procedure of preparing.
So the first procedure is you add onto the zinc sulfate, you add sodium and sodium carbonate.
Continue.
Then you mix the solution using a glass rod. You allow the solid to settle. Then you pour the excess liquid off. Then you wash the solid, which will be zinc carbonate. The zinc carbonate will be formed and sodium carbonate. Then you get zinc carbonate.
There are some key points you didn't mention. You talked about wash with distilled water. I didn't hear you talk about wash with distilled water. You must mention the word distilled water. You didn't talk about drying. Those are keywords. Those are where marks are. Is that clear?
Yes.
Yes. Okay, that's good. I can see Mugambi, you're raising your hand. Let me give you another substance.
No. Excuse, can somebody use a nitrate?
A nitrate to do what?
The preparation of zinc carbonate.
Yes, you can use, because zinc nitrate is soluble. So once you take zinc nitrate, which is a soluble salt, it has zinc ions, and then you use a soluble carbonate like potassium carbonate, sodium carbonate, or aluminum carbonate. Those are all sodium, potassium, and ammonium salts are soluble. You can use those two to prepare. It is correct. You can use. Another question? Another question? Mugambi, you're raising your hand. Yes, you just go ahead. You can ask. Mwalimu Nyamaz. Okay, someone is. Austin. Austin, you're raising your hand. You can ask. I can see people raising their hands and they're not asking. So probably I'll need to move on. Yes, there are two people who've raised their hands. Ask if you have a question.
So in this experiment for preparation zinc carbonate, it's going to be okay if you use like any soluble salt, as long as it's soluble, like for how do I
zinc chloride.
Zinc chloride plus which is soluble zinc chloride, and magnesium carbonate.
Magnesium carbonate is insoluble.
Which is insoluble. So it's going to give you the same result.
No. You have to use two soluble salts. If you use zinc chloride is okay. Plus magnesium carbonate. Magnesium carbonate, it is not correct because magnesium carbonate is insoluble. You can only use sodium carbonate, potassium carbonate, or ammonium carbonate, because those are the only three soluble carbonates.
Yes.
Yeah. So whatever you choose, you must be sure that it is soluble.
Excuse me, Chair.
Yes, Njoroge.
When in the experiment of silver chloride, in your notes you have written that you should allow the solid to settle, then pour off the liquid. Is it correct to say that, or you can also say allow the silver chloride to settle, then pour the sodium nitrate?
it is correct. But whether you mention them or you do not mention them, well, what will give you a mark is talking about allow it to settle. That's what will give you a mark, not mentioning them, mentioning that the solid is silver chloride and the liquid is sodium nitrate. No, what will give you a mark is saying allow it to settle and then you pour off. Or in place of this, because this process is decantation, then you can talk about filter the mixture and wash it with distilled water. Is it clear?
Yes.
Okay, that's good.
Yes.
Yes, Kerry. Someone was talking. You can ask a question. Ernest Mumo.
In the reaction between lead nitrate solution and magnesium sulfate, why do we add excess magnesium sulfate?
It is to ensure that all the lead ions have precipitated. To ensure that all the lead ions have precipitated. And again, we will be removing the excess magnesium sulfate, magnesium ions when we'll be washing with distilled water.
Okay.
Just to ensure there is nothing that is excess that is left out.
And also, what do you mean by the term precipitation?
You see, precipitation, let me give you this example. You see, when the rain falls, the rain is precipitating. That is, it is coming down, it is falling down. That aspect of something is in a solution, but it leaves the solution and then falls down. That falling down is what is called precipitation. That's why we said two ions, there is exchange of ions. Once the ions exchange and they form an insoluble salt, that soluble salt falls down. It decants, it moves out of the solution. Precipitation means falling down. Snow also precipitates. It's an aspect of falling down. Is it clear?
Yes.
Okay. Any other question? I think we are clear with that. So I would really want everyone to know how to write. I would want to give you about 2 to 3 minutes. Could you write this procedure? Write this procedure so that you can have the keyword of knowing how to write a procedure on the preparation of insoluble salt. Kindly do so. There are only 3 points. These 3 arrows. These 3 arrows. Do so. They will also write the examples, but please take time and write those 3. I'll give you some time, about 3 or so minutes. It is now 10:05. Let me give you some few more. There's still another concept that I really want you to understand. I hope time is going to allow us. So I want you to take this time to write that procedure, have it in your books, and then I'm going to give you some examples and see whether can you really write a procedure of preparation of an insoluble salt, of any insoluble salt. So 1 minute is down, but you can also tell me if you're through. You can just tell me that you are through so that you can move on. I'm just giving 3 minutes so that you can copy that procedure. Remember, it's only these 3 bullets, 1, 2, and 3. Just these 3, that will be enough. That will be enough. 1 minute is down. You have 2 more minutes to copy the procedure. Once you're through with the procedure, please could you underline? The 3 minutes are over.
A minute, teacher.
A minute, okay. A minute then to the one who has requested. I would really want you to note, because these are free. These are 3 free marks. And again, please underline where I'll try to identify again to show where the marks are. I'm trying to I'm not sure whether that is going to cancel. Where there is lead nitrate, that's underlining. And then where there is excess, no. Where there is excess magnesium, that's another place where there's a mark. You have to identify those 2. And then number 3 is where you mix them. So note where I'm underlining. This is where the key marks are. You mix them with a glass rod and then allow it to settle. And then you pour off. That's where another that's 1, 2, 3. Now the noise there. Yeah. Now someone needs to mute themselves. Then again, wash with distilled water. That's another key point. And then lastly, where you filter, actually, basically, is you filter and then you dry between filter papers. Must also say, someone is it's unfortunate. Time is really moving fast, so now those are the key things. I've just underlined them. Identifying the two soluble salts and then mixing them together. Number 3, how to separate them. This is using decantation. You could also say filter the mixture instead of allow it to settle and then pour the liquid off. Filter the mixture, then wash with distilled water and filter. That will give you another half a mark, and then dry between filter papers. Please underline those keywords. After you've underlined them, then that will help you in the same. Okay, I want to believe that you are through. Actually, I've given you 6 minutes. There are some examples here. These examples have equations. So that means that you'll also need to identify the insoluble salt. For this case, there's barium sulfate. Then you identify the 2 soluble salts that are making, and you should be able to write an equation, a correct chemical equation. And remember, The insoluble salt has S as a solid because it is insoluble. And then the other soluble salt is in aqueous form. It is in aqueous form. I don't intend, the next part is in writing ionic equation. This one I'll refer you to your textbooks, KLB. It has very good examples on writing ionic equations. As long as you'll be able to write these equations, then it will be, it is going to work well. I'm going to also ask you to write down these examples. Write down these examples. It's going to be used as a good starting point for you in writing ionic equations. So probably I would give maybe 5 more minutes and then you can proceed on. So please take the next few minutes and write those chemical equations. They're very important. This is also a very common example, writing a chemical equation for the formation of an insoluble salt. So we have looked at the procedures. Now next is to write the chemical equation. So take the next 5 minutes to write the 4 examples that are on the screen. So you will need a lot of knowledge on your writing of chemical equations. It will be an opportunity. Again, you need to go back to the table in your KLB books on soluble salts and insoluble salts so that you're able to identify the correct soluble salts that will be used to prepare a soluble salt. I'm just giving us some time. 1 minute is over. Okay, You have 2 more minutes to copy that. I'm going to give us some time for any questions. One more minute. I'm going to give us 1 more minute just in case there's someone who has not completed, so that we can get any questions and hear my examples. Your assignment, as I can see, time is almost over. Your assignment is going to be on ionic equations. I want you to look at those examples in your KLB so that you can go through them and write them. Hopefully, in the next lesson, the next teacher is going to guide you in the ionic equations. It's going to guide you in the ionic equations. That's also very key. In the preparation of insoluble salts, there are usually 3 key parts. Number 1, are you able to write a procedure? A procedure in the preparation of insoluble salt. Number 2, are you able to write a balanced chemical equation for the formation of an insoluble salt? That is number 2. So the time we've had, we've been able to look at the procedure. Number 2, some examples of equations that show the preparation of an insoluble salt. And be very careful to note that the insoluble salt is denoted by an S and not AQ. The others are noted by AQ. They're noted by AQ, basically. Again, when you're identifying, after identifying the insoluble salt, be careful to identify the 2 soluble salts. Okay. Those are now 6 minutes. I hope that is clear. Is there any question? Well, then I want to believe there is no question. You can unmute. If you have any question, you have any challenge? Okay. Let's move on. We've talked about ionic equations. Ionic equations. Let's look at the following. I would want us to watch this so that we can see how they are written. Hope time is on our side.
This video is on ionic equation and how we write ionic equation. So let's get started. Basically, ionic equation tells us ions are involved in the formation. Okay, so basically, what are the ions that are involved zinc equation. So that's the alcohol equation. From salt and water. First thing that we do, write down this. On it, the other video, okay. Unless it's here, this equals equations are balanced, this equals down. And ionic equation, the aqueous product. Okay, the aqueous reactant.
Ernest, you've raised your hand.
Yeah, ion. But okay. Water is a liquid. It doesn't break up. Hence, it's as a water. Now let's look at the ions and ions that are present inside solution. We so that
I can see some hands are raised up.
these are
Who is raising? Yes, Ernest. Also, someone had raised their hand.
responsible for the formation of water. So this is what ionic equation.
Excuse me, Cha.
Yes.
The video that you're screen sharing, it's not that loud. I cannot hear anything.
For this one, let me get another one.
Yes.
Precipitate of silver chloride will form.
In this video, we're going to focus on writing
Is it clear?
ionic equations for double
It's not visible. Excuse me, Cha. It's not
Yes.
visible.
They've not put anything.
We can't see a screen.
We can't hear.
Say we have an aqueous solution of magnesium chloride and silver nitrate. What are the products of this reaction? Now, the first thing
Just follow the equations for now.
is if you have a single replacement or a double replacement reaction. Now, we have a reaction that's in the form AB plus
Please screenshot.
This is the double replacement reaction. Magnesium is like A, chlorine is like B,
Just follow the screen for now.
and D is the nitrate.
Check if not share the screen.
Just
You're
follow
not
the
screen
screen.
It's going to pair up with D.
There is no screen.
There is
There's
no
no
screen.
There's nothing on the screen.
You cannot see anything.
Yes.
Yes.
So,
Just a minute.
Just a minute. Minute break.
So ukienda break utasoma aje ionic equation?
What?
Equations are valid. Basic those. Now, HCl is solid. It's insoluble. So, very break up. Or you can. Okay, you can pause the video and cancel the ions that are present on both sides.
I kindly share the screen.
Nitrate.
Can you see anything there?
What is left is silver.
Yes. Yes.
Yes.
Okay.
Yes.
Yes. Yeah.
And the volume?
HCl is solid.
No.
Oh, we cannot hear anything.
At the volume.
At the volume.
The video is the one. Let me see, because the volume is not very clear.
Mama who?
You don't know.
Pampas.
I think I need mute.
Mama what?
Okay, I think we are hearing what we should be hearing. Pole kwa yule analia. Now, we only have 1 minute, but probably it will not take much time. I'll just give just a direction, and then I'll just give an example, and then we go, because some of you also want to go for a break. It's not yet break time. Let's look at this example. Their video is not very audible. Now we have silver nitrate and sodium chloride. These are two soluble salts. We have sodium nitrate and silver chloride. You can see that silver chloride is insoluble. So how do you write the ionic equation? You have to write the ions themselves. Now from silver nitrate, it is aqueous. So you have silver ions and nitrate ions. Sodium chloride is aqueous. So you have sodium chloride and sodium ions and chloride ions. Again, you have sodium and nitrate ions. So we have sodium ions and nitrate ions. Silver chloride is solid, so we cannot show the ions because it is a solid. So the first thing, once you write the equation as we had said, the next thing is to identify the ions present. After that, you need to eliminate the ions that are present. Just a minute. I want you to see how the person is eliminating the ions. Sodium, sodium, eliminate sodium and sodium. Nitrate, nitrate, eliminates the nitrate and nitrate. So you left with silver and chloride, silver chloride. So the ionic equation becomes? Yes, now that is an ionic equation. Now for you can, that is one example. Your assignment will be looking at more ionic equation. Writing ionic equations for the equations that you have already written. I think we'll stop there so that we don't take much time. You can refer to your KLB books. They have very good examples on how to eliminate, on how to write ionic equations. You can also go to YouTube. There are good videos that show you on how to write ionic equations. So in the preparation of soluble salts, there are three key things: writing procedures, number 2, writing the equations, and number 3, writing ionic equations. You should be in a position to handle those 3 areas. Thank you very much for your cooperation. Thank you also for your time. I hope you have learned something. Those who want to go for a break, you are free to go for a break. Unless there's any question, that you have. Yes.
When you're writing ionic equations, you derive them from when you are writing the preparation of
insoluble salts.
Yes, insoluble salts.
Yes, actually you will get them from the equation itself. You can see the video that you have just watched. You write the equation. From the equation, you identify the ions. Then from the ions, you can now eliminate the ions, the ions, the expected ions, and then you just eliminate just as the way you have seen.
Thank you.
Then you can continue.
Thank you.
Welcome. Thank you very much. Have a good day. God bless you.
You too.
You too.
Same.
You too.
Thank you.
Same.
Make sure you write those
You
ionic
too.
equations.
You too.
Okay.